What are equivalent fractions and how can models help us with this? We're looking at a fraction 8/16 right now. And here's our model. We have 8 out of 16 pieces are shaded. So an equivalent fraction would be two or more fractions that name the same part of a whole. When I look at this picture, I say that, well, half of the pieces, half of the 16 pieces are shaded. So 8/16, so let's get our pen here. 8/16 is equivalent or equal to 1/2. We need to understand equivalent fractions for many reasons. Sometimes we need them when we add or compare, or we're looking at two different fractions and trying to think which one is greater or less than the other. So let's look at a couple other examples here. Sometimes we have to create equivalent fractions to add unlike denominators. So when we look at one here, like 5/6 plus 1/2, 5/6 plus 1/2, using rectangular fraction models, whoops, and here they are. I know that a half is equal to 2/4 is equal to 3/6. These are things that we already know, and they are all examples of equivalent fractions. When you add them, then you get 8/6. So sometimes you end up with an improper fraction, which we'll talk about a little bit later. Here's some other examples of equivalent fractions. I'm going to make this a little bit bigger for us. Okay, and we can use fraction strips that represent fractions that are similar. For example, we could see that here's 1/2, and we know that 2/4 is equivalent to 1/2. So in this example, I'll make that a little bit larger. There we go. In this example, that's better. All of the yellow fractions are equivalent. For example, 1/3 is equivalent to 2/6. And then we have 2/5 is equivalent to 4/10.